Good afternoon, everyone. My name is Sherwin. Thank you for joining this webinar. Today, we would like to share machine to intelligence solution for the smart industry. So we will have a 3% to do the presenting. Our key account say LT Pan. My name is Sherwin. I'm senior application engineer. So we also invite Ajay from Miraya, who will be sharing for success story. This is to the agenda. I will share with WISE-EdgeLink Studio the software. Secondly is for the HSRP product introduction. The third one will be the success story sharing from the Miraya, Ajay. The fourth one is I will do simple demo and share for how to use our ECU 1051 and Adam. The last part will be the Q&A session. Right. So why we are saying is machine to intelligence solution, because our software itself, they are able to communicate with the different kind of the machine and equipment. So they can do for the data conversion, protocol conversion, and then they will do for the processing. After that, they can be able to publish all this data to the private cloud or public cloud. Right. So our software solution is the mainly what target on the three vertical sector. One will be the equipment monitoring, and the second one will be the machine monitoring. The last one will be the facility and energy monitoring. So our success story is mainly related with the energy monitoring, is solar energy monitoring. Right. So the next slide we will share more on this section. So what is the EdgeLink, the software? EdgeLink software is purely the gateway software. They will not come with the visualization, right? So they are lightweight. They can able to run for the cloud platform. So designed for the cloud platform. That is the reason our software is we can be able to run on the different kind of the Linux, the operating system, right? So the end user is they don't need to write any programming. They just need to be configured for the different kind of the protocol, so they can able to catch up to develop their project. It should be the short timing. So our software, EdgeLink software, is that they also can be communicate with the multiple cloud platform with the third-party system, right? So the EdgeLink software, you cannot be purely buy our software. They always come with our hardware together, something like all. This is all the hardware prototype is like that. So current version is the version 2.8.0. Right. So all this information you can get it from the Advantech website. But this is our WISE-EdgeLink software overview. So if you look at from the top bottom layer, you will be see that they will be provide supporting is the 200 type of the driver will be supporting. Right. So this software is that they can able to run on the different type of the Linux platform. So we just indicated that 20 plus of the Linux platform, we are able to run it on the different hardware. Right. So all these function and features I will share more on the next slide. Right. So EdgeLink, the software is I will categorize into the four main group. One is for the data collection, right? So data collection is that they will be covered to be the data acquisition, protocol conversion, data pre-processing, right? The second is the data management. So how you want to manage your data? You can do for the data logging. You can do for the data backup. You get based on your data, you can be able to set how to set for the alarm trigger and event, right? So some of your data, you also can be make it to be port forwarding, subject data forwarding, right? So this is the function will be under data management. The third one is for the security, right? So our security will be supporting for the three things. One is the VPN, using another second one will be the OPC-UA. The last one will be the whitelisting. The last portion is publish services. You can publish all of your data to be the cloud. So let's start from the data acquisition, right? So this one will be under data collection, right? So first step, you will need to be collect your data. So we in our first slide, we did mention to you is our software itself will be support different kind of the driver, protocol driver will be supported. This is the driver list when you do for the project configuration, right? This is the driver list. So you can able to set up your polling scan time. What is the scan time? You can be able to set it for data acquisition, right? So this one is for the data acquisition, right? So why I will share data model in this slide is that when you set up for the data acquisition, right? Let's say, for example, you will have a same module for same project. You will need to be configured one by one, right? So let's say if you create the template, right? So the layman term will use the template, right? So you can use the template. You create the one template. You don't need to be create individually check one by one, right? Something like this is that information one by one. You don't need to be create one by one. So you just create for the one template device model. You can be reuse it subsequent and reuse it. This one will be quite helpful to you to shorten your project development times, right? So after the next step is after you get the collected your data, right? So definitely you will need to do data processing, or you will need to do data scaling. I give you one example, right? So normally if you receive the data, let's say if you're using is the analog signal, right? If you're receiving the data, your data maybe may not be the meaningful data. Maybe you are giving 0 to 10 volt, 4 to 20 milliampere, right? So you will need to, according to your sensor spec, your equipment spec, you will need to do for the data conversion. Maybe let's say we will call this thing to be the scaling, right? You need to do for the scaling, right? Some of your condition, you will need to do certain computation, right? That's the thing. You will need to use the calculation, right? We call the calculation point, calculation check, right? You will need to do calculation, right? So sometimes if you want to be set certain parameter for your computation, right? You can use the user tag. Let's say if you do for programming, you will need to be declared for a variable, right? In our software, we call the user tag. This is the call, just the naming different only. So all these things is will be used when you do for the data preprocessing and data computation, right? You will need all this functional, right? So sometimes our calculation tag or our computation may not be meet your requirement. So we will be provide three different software programming is you can be used in our hardware, our EdgeLink platform. One is we call the IEC 61131. Actually, this is the one of the standard PLC programming language, right? So you can use the PLC programming language. You can do process control, or you can do certain computation is need by the project requirement, right? So this is one of the programming. Secondly is our software platform is running under Linux, right? So we will be supporting for the C programming, right? So we will provide for the development environment, we'll provide the SDK documentation. You can be referred to these two documents. You can be create and do for the C programming in our platform. So they can be combined and used together. So the third one is the node web programming. This one is the optional, right? So why I'm saying it's the optional. Let's say if you buy for the our one of the SRP hardware itself, right? They will not come with the node web programming itself. This is the optional. So our standard image will not become with the node web programming, right? So let's say if you need for certain programming, if you are familiar with the node web program, yeah, you can talk to our support team. So we will guide you. We will provide the document how you to be set up the node web programming in your SRP hardware. Right. This is the three programming is for the mainly they will use the process control and data preprocessing. Right. We also talk to you is the under data collection is the right. You will need to do for the protocol conversion. So this is the one of the features is we just give the name is the protocol conversion. I give you one of the example is you will be see from this slide itself, right? So this is our WISE-EdgeLink. The software is running on our hardware, right? So let's say the the lowest layer is, let's say, is the running is the OPC UA server, right? So this is the server. Our hardware, they can be able to do. If you want to pull the data, it will be set up to be the client, right? So let's say if you have a third-party OPC equipment, they want to get the data from our WISE-EdgeLink, the software is right from communicate with our hardware. We can be able to set up for the OPC server also, right? So you will be see from here. We are doing for the protocol conversion is the reason is we can do for the OPC client, OPC server at the same time. That is the we are giving one of the example is using is the OPC protocol. They are showing to you is we get our hardware itself we can do for the protocol conversion, right? So in my hands-on part, actually I will use for the Modbus to simulate Modbus server and client for this scenario. Okay, the second part is we call the data management, right? So after you query the data, you have done data acquisition, right? So you will need to do for the data logging, right? You may need to log all this data, right? So if you want to do for the data logging, log your data, you will need to do two things, right? So according to your hardware, some of the hardware you will see from a small hole, right? This is the USB port. Some of the hardware, they may not come with the USB port, okay? So one of the way is you can use the USB, let's say if your hardware have a USB port, you can use the USB stick to do for the logging. Let's say your hardware, they will not come with the USB port itself. We have another hardware, we can use the micro SD slot. They will come with most of our hardware will provide micro SD slot for data logging. You can use micro SD card to do for the data logging, right? So this is the one of the function we call for the logging, right? So after you log this data, what actually you want to do? Maybe I want to backup and save in our backend database, right? So you also will be, this is the core function we call the backup function, right? We will provide a few database we will be supporting. One is the Oracle database. Now, second one will be the Microsoft SQL database. The third one is MySQL database. Maybe this slide is not, I forgot to add in this database. The last one will be the FTP server. This is a few way you can back up your data in the backend server, database server, right? So in the under data management, we also can, based on your data, you can set certain condition. Maybe one of the example, right? If you're trying to reading temperature value, right, you can set it your threshold set point. If the temperature is overshoot or undershoot, you can be able to set based on your condition, right? You can be set up threshold and then you can be trigger your event, right? So we will have a two method to trigger your event. Okay, one is email, another one method is for SMS, right? So these two methods you can set up for alarm notification. We call it event trigger. Just a naming different. Okay, right. So one of the part function is we call the port forwarding and NAT. Actually, this is the two function, right? Two function. Let's say your data is coming from the internet to external network or external network to internal network, right? So you can be set it to the port forwarding or NAT function, right? So these two function is one of the features you can be set it in our EdgeLink, the software itself. Right, so this is a third major group is we call the security, right? So our software is will be providing a web service. Based on the under web service itself, we will be support is HTTPS, come with the SSL, right? So let's say if you're using is the MQTT, we also will be support that DNS version 1.2, right? This is for the web service security part. The second one is the configuration, right? So when you do for the configuration, definitely you will need to be use the username and password user level. You can make for security thing is all of your configuration setting and project file will be encrypted using is the AES-256, right? This is for the configuration part. So for the transmission is we will categorize into the two groups. One is we call a whitelisting. Whitelisting, what's the meaning of the whitelisting? You can set the whitelisting in your configuration is you allow which IP you will let them to accept your software, your data. Yeah, this is we call the whitelisting. They use the IP base to do for the whitelisting, right? You can set up which IP allowed to access your data, right? This is we call the whitelisting. Second one is that if you want to be communicate securely, you can use the OpenVPN, the method, right? This is the encryption method our VPN is supporting, right? So let's say if your VPN setting is some of the VPN setting, they will have two method authentication, right? You will need to get certificate. You will need to put for the key pairing, right? This is one of the features under, I would say that under OpenVPN setting, right? You can see all this configuration setting will be like that, right? So this is the project configuration, right? This is OpenVPN setup. This is the one I did mention to you is this is what kind of the security method we are able to providing, right? This is the one, right? So let's say if you want to do for the two authentication mode, right? Definitely you will need the certificate. You will need to do for the key pairing is the server side. Definitely server client, the method, you will need all this information. You have to be key in your OpenVPN setup, right? This is one of the features for security. But second one is I did mention to you is we will be providing is web services, right? So our web service is designing with the HTML5, so they are able to run on a different kind of the browser. They are able to run it. Okay, so you will see that our software they will come with a built-in RESTful web server. So we also will be support the OTA. What is the meaning is OTA is actually OTA is over to the air, right? So if you use the web service from remotely, you can be able to use the OTA method to update your flashing your image and all these things. Yes, you can do that using OTA. This method is you can do that. You also can use the web service, all this function. You can be able to check what is the image, editing the image you are using, version of your image. You also can be checked with the connectivity for your communication, all this thing. And then you also can be check all this information for the system status, right? One of the slide I did share some information about for the system slide. You will be see from all this information in the next slide. Right. So the last part is data publishing, right? So after you collect the data, you can do for the protocol conversion. I did mention in the previous slide, right? So after you get all this data, right? Definitely, if you want to do for the publishing, yes, they will have a few ways. You can use the OPC or you can use the MQTT this method to communicate and publish, talk to the different kind of the cloud services. This is the sensing device. Actually, it's sensing device. You also can be think about it. This is the data gateway sensing device to the cloud. This portion will be handled our hardware itself. So this one is for the cloud side, right? So cloud side, after they get the data, they can able to do for some kind of the analytic software. You can be able to do that, right? This one I will not mention too much on the cloud side, right? So this side I only will be focused on our hardware itself. Yeah, you can use the MQTT, you can use the web service, you can be publish all this data to different kind of the cloud, right? So this is the some configuration setting for the OPC. Why I put this slide in the cloud side, because if you look at from this architecture, right, OPC itself, they can able to do for the protocol gateway, right? So protocol conversion, they can do for the server client, okay? Server client. Why OPC also sometimes they will use for the cloud is they also a new version of the OPC, they will be supporting PubSub, the method similar to the MQTT, right? They also will be used PubSub, mainly is designed for cloud services, right? So that is the reason I put in the OPC. still will be under data publishing, right? So I did mention to you is the system information, right? This next two slide is actually mainly designed for the troubleshooting and the monitoring for your hardware, right? So if you look at from this side, we call the system depth, right? System information, right? You are able to know what is your system uptime, what is the current CPU usage. You will be see from current CPU usage, right? So you will be able to see that CPU performance. You can do monitoring for your hardware performance. You can use our system information to check for hacker condition for your gateway itself, your hardware. So one of the function we call the ICT manager, right? So please take note, one thing is that this function is mainly you only can be used for one of our hardware. We call the Adam 3600 or this SRP, the hardware itself. Our sales, Mr. Pang will be shared with you later. So what is the main purpose of this function? This function is mainly is used for the to checking for your communication, physical communication. I will say that the physical communication, right? So they are mainly designed for COM port and checking for the Ethernet port. So this is the two function, two physical hardware. We can use the ICT manager to do for the checking. Okay, I will let our key account sales Pang to share on the SRP product introduction.
Hi everyone, I'm LT Pan, KA Sales from Singapore. I will cover the machine to intelligent hardware portions. I will continue the slide by introducing Advantech Edge Solution Ready Package product introduction. First of all, I would like to introduce our ADAM 3600 Intelligent IoT Nodes. This product can bundle with our WISE-EdgeLink to become a ESRP PSCS-ADAM 3600. This product equipped with 32-bit Cortex-AX 600 MHz CPU and 255 MB RAM, and it also having 32K battery backup RAM. It's run on the RT Linux version 3.12, and they're having a SD card slot for data storage. It's also ready for PC or PLC programming. We provide SDK for C programming and also IEC 61131-3 soft logic. We also supporting multiple protocol like OPC UA server, Modbus RTU, Modbus TCP, BACnet DMP3, and Open VPN, and so on and so forth. Okay, we also support wireless communication, like we provide two PCIe mini card module which support Wi-Fi, LTE, and Zigbee. In this module, we also able to plug in multiple selection of I/O like AI, ADI, or DO. Okay, we having 4 flexible expansion slots and also having a LED indicator. For this module, we also support RS-232 or 485 with DB9 connector, and also 2 RS-485 with terminal block. We also having 2 RJ45 ports. This module also support wide temperature range from -40 degrees to 70 degrees Celsius. So as mentioned earlier, it has 4 flexible expansion slots. You may choose 4 I/O modules from this table based on your project requirements. So what module we have, you can see from here, we have ADAM 3613 with 4 RTD, or maybe ADAM 3617 with 4 AI, ADAM 3618 with 3 temperature, and ADAM 3624 with 4 AO. So forth and so on. You can choose 4 from the table. The main target application are for equipment condition monitoring, facility monitoring like data center and pump station, or for remote maintenance. The next few slides, I will show the example for those applications. This is one of the example applications for low voltage distributor monitoring. It's via communication port and also getting the I/O signals from the field side to our ADAM 3600 Edge intelligent device, which is a data acquisitions, local storage, control, and communications all in one compact device. It can directly send the data to the cloud without a gateway. So this slide shows the commercial building HVAC energy monitoring and control system connecting via backnet and Modbus protocol to ADAM 3600. Next, this is the gas station monitoring and control system via OPC UA. WISE-EdgeLink support OPC UA server or client, and also HDA means historical data access. It provides secure communication between the field and the SCADA. This slide shows one of the application example for ground support vehicle remote monitoring and cloud management. With logging the sensor data with timestamp, part ID and with GPS positioning, operational times and system status, the user can monitor all the sensor data, operation times, the position of the tug on map and alarms. Okay, next, we would like to introduce ECU 1251 bundled with WISE-EdgeLink. The product number is shown above the slide. This device supports PLC and meter protocol, support DLMS and DL945 for power meter, having RS-232 or 485 and LAN ports, with 4 serial ports for different protocol conversions. For the data published service, it supports OPC UA for SCADA, some legacy protocol, remote backup for SQL and Oracle, and data store and forward. The target application is for advanced metering infrastructure, connected equipment, and facility monitoring. This ECU 1251 had certified by Dutch Telecom, Microsoft Azure in Azure Certified Device Catalog and Amazon AWS in Partner Device Catalog. In the next few slides, I will show some application example. This slide shows the cooling tower online monitoring. By connecting the cooling tower via a communication port to ECU 1251, it allows data acquisition and logging, control and communication in the edge intelligent device. Data can be sent directly to the cloud via LWM2M without a gateway. This allows the user to have performance monitoring, system optimizations, and energy saving control. Similar to the previous slide, this elevator online monitoring also connects via a communication port, but send the data to cloud via OPC UA. Okay. Next, as for this slide, show the OT network security application example in which all the field devices and equipment are connected to a network switch via internet before being connected to Advantech ECU 1251. This allows the user to have an adjustable Modbus port number, separated command to protect read and write of the device and access IP protection by whitelist. Okay, next, the last example is a SCADA-based temperature control monitoring system. As shown here, all the sensors and devices like leakage detection, temperature sensor, pressure sensor are connected via the Modbus RTU, and the barcode scanner is connected via USB to Advantech ECU 1251. At the upper level, it is flexible to have wired or wireless communication interface. Data will be sent to SCADA server or to the cloud. Next, the third device I would like to introduce is ECU 1051. It is more compact size, comes with RS-232 or RS-485 and LAN port. It also supports PLC and meter protocol. For data published service, it supports MQTT, LWM2M, data store and forward. Device status can be monitored by using the system tag. It has dual SIM slot to support redundancy communications. The target application for this device is for advanced metering infrastructure, remote maintenance, and energy management. Okay, this is one of the applications example for energy management system. ECU 1051 had been deployed in the supermarket by collecting the real-time data from all the temperature controller, freezer, power meter, and bleeding pool controller by using Modbus protocol. Then the data had been published to AWS Cloud via WISE-EdgeLink. Okay, next, this is the last product called ECU 4553, which have 4 LAN ports and 16 RS432 and 485 ports. It supports time synchronization (NTP) and has rack mount installation for substation and data center. It's running on TI Cortex-4 A8 CPU and 1 GB DDR memory for high-speed data storing and forward. The target application is for infrastructure, energy management, and substation communication gateway. Okay, next, I will show some successful case study. For this slide, this is a IoT-based power generation data collection successful case study. The data is collected from the weather station through the Modbus TCP protocol to our WISE-EdgeLink ESRP product. All the solar inverters are also connected via Modbus TCP protocol, which follow the IEC 60870-5-104 standards. Okay, from here, all the data will be sent to the cloud by using the MQTT, or also it can be sent to your on-premises server or computer by storing your database. Okay, next is a similar application for the SCADA-based power consumption monitoring system. Instead of using the Modbus, the smart meter are using the DLMS, also the DLT645. And then the smart meter is using the Modbus and also using the DMP protocol. The data will be collected by using our ESRP product and data sent out to the SCADA server via the IEC 61850 MMS. Okay, next, this is a similar case study. The IO, instead of sending to the SCADA server, the data is sending out using the MQTT through to the cloud services. Okay, next, this slide shows a distributed equipment remote monitoring system. So you can see this is a mobile power generator, also connected via the Modbus RTU to our ESRP product. And then we are sending out the data via the MQTT to the cloud by using the 4G LTE. And then below is the low voltage distributor. All the analog input and digital I/O is connected to our ADAM 3600 via the Modbus protocol. And then the data has been sent out to cloud using the Wi-Fi via the MQTT protocol. The next, this will be the last example from my side. From this slide, is shown the water pump station central monitoring systems. As shown at the bottom, all the pump has been connected to our ADAM 6000 series I/O module. All these I/O modules is using the LAN port connected to a switch, and the switch is connected to the ADAM 360 and also to the upper level to the internet, or also to the SCADA systems. So this is the total solution provided by Advantech. Our ADAM 3600 has been implemented as a field data concentrator. It collects all the data from the remote I/O modules and send the data to central monitoring SCADA. So this is all for my presentations. Thank you for listening. Now I will hand over to Mirai to share their successful case story on how they implement our products and solutions to their solar monitoring system. Thank you.
Hi, this is Ajay from Mirai. Today I'm going to talk about how solar PV monitoring systems using Advantech products has enabled our customers to maintain long-term performance of their systems. We will begin with a general introduction to the PV monitoring, followed by a typical system architecture and key performance indicators for a solar PV systems. Singapore aims to install roughly 2 gigawatt peak of solar PV generation capacity by 2030. Singapore has a very high annual solar insolence or irradiation, as you may call it, of about 1580 kilowatt hour per meter square. This is about 50% higher than temperate countries. Being carbon neutral, Singapore government is planning and encouraging adoption of solar energy in the country. As you can see, having such a high irradiation, it makes a lot of sense for Singapore to adopt solar energy. Before I go into the details, a brief introduction about Mirai. Mirai was established in 1998 as a component trader. We progressed into PCB assembly and turnkey projects, followed by supply and installation of substation RTU to SP Group. In 2010, we participated in IES Smart Meter Initiative by EMA, and we eventually qualified to supply power meters to SP Group, which we are continuing till date. In 2019, we started investing in solar PV market, and in 3 years since, we have grown into be #1 solar PV monitoring vendor in Singapore. Our products include supply of hardware like energy meters, edge devices, routers, and similar other products. We also offer a multitude of allied services like fabrication of comms DBs, DB panels, as well as system integration services of PV monitoring systems, together with installation and commissioning of sensors and inverters. Now, how do we really measure the performance of a solar PV plant, knowing fully well that the amount of sunlight is not constant throughout the day? There is a method to calculate the performance of the solar PV system, which is called performance ratio, which in turn is a factor of total irradiation of the day and the generation during the same period, together with the installed capacity. This performance ratio is a value from 0 to 100%, and optimal performance would be from 75 to 90%. Apart from this, the PR also takes into account, for example, the temperature of the solar panels, as well as the minimum irradiation needed to start generation. For example, you may have an irradiation of, let's say, 50 watt per meter square, but the system plant would not be able to function or even start generating or pumping energy into the grid. So any of those values that do not allow the plant to function have to be discarded before calculating this performance ratio. In terms of the monitoring of the system, or of a typical PV monitoring system, there are two parallel tracks going on at the same time. One is the real time, which is primarily meant for events and alarms for abnormal situations. For example, inverter may have tripped, or there may have been a loss of power from one of the strings, or a total failure of a string, or for that matter a tripping of a circuit breaker. So these kind of alarms have to be reported in real time so that customers can attend to them immediately. The other track that is required to be reported periodically is on the daily performance, generation, and other historized parameters, for example the temperatures and the rainfalls, and in some cases it's required to monitor some other parameters, for example wind speed, if your structure were to be susceptible to high gusts. In terms of the long-term performance of the solar PV systems, it is well known that the life of solar panel is finite, which is about 20 years, 20 to 25 years, which also gives rise to another factor, that there is a gradual degradation of output from the solar panels. So in the first year, for example, performance is not the same as second year performance, and and that one is not same as the performance in the following years. However, there is a fixed, I wouldn't say a fixed, but a generalized pattern on the degradation, which is, let's say, maybe 1% per year or some around those. Effectively, we as a PV monitoring supplier have to monitor this degradation of performance over a period of time to be able to achieve or to be able to analyze whether the system is performing optimally, or is there any degradation, or does the system need any maintenance at a certain point of time. For example, in the first year, the performance may have been 85%, performance ratio may have been 85%. However, the second year we do not expect it to be that high. It could be maybe 84%. However, if the performance ratio falls below that value consistently over a period of time, then we need to analyze why that could be so. So the key parameters that we need to monitor for achieving our end results of a reliable systems operation is the incident irradiation, the instantaneous irradiation, and the power, to see whether the system is working or not. For example, if you have irradiance and there's no power, then there is something wrong in the system. Secondly, if during daytime there is no irradiance reported, there may be something wrong. The panels could be dirty, or maybe the sensor is damaged, or any such thing. Secondly, the most important real-time monitoring is the status of breakers, contactors, and inverters. For example, inverters may have tripped, or breaker may have tripped. That needs to be reported immediately, as it directly affects the revenues of the customers. On a periodic basis, we report the irradiation, the total amount of sunlight falling during the day, and the amount of energy generated by the plant on a daily basis. This is then fed into our algorithms, which then calculate our performance of the system in the short term, which is the daily performance ratio, and analyze the same over a period of time, whether system needs maintenance or attention. Now I'm going to introduce to you a baseline system architecture that we use in most of our plants, which are roughly now almost 150 plants that we monitor today in Singapore. On each plant, we generally use EdgeLink devices, which primarily, as of now, we are using ECU 1051, in some cases ECU 1251, and moving forward we will be using ECU 1252 because of strict cybersecurity regulations in Singapore. In some commercial buildings, we are using UNO 2484 because they need some local analysis to be reported there itself, and those may or may not have internet connectivity, and for those reasons we need to store the data locally and report it locally. The ECUs and the UNO SRPs, they send the data to the backend systems, as has been indicated, to our web access SCADA, which then does the processing of the data, historization of the data, and on top of it, we supply our algorithms to do the data analytics. A typical site looks like this, with all the sensors generally connected via 485 Modbus, or as we all know, ECU 1051 can handle a lot of protocol, so we really don't have to do any additional scripting on 1051 or any of the EdgeLink devices to be able to read any kind of peripheral or sensors in the field. And then this EdgeLink device sends the data to the backend, be it web access SCADA or device on BI kind of SaaS platform. In summary, we use a combination of Advantech products to meet our goals. We recommend generally, in general, SaaS model, which is based on device on BI or data management system. Or if the customer prefers, we recommend using web access SCADA into their on-premise or self-hosted servers. For reporting the data from the plants to the backend systems, we use products like ECU, which are basically EdgeLink products, as well as ICR 3231. I would say ICR series of routers that have proven to be very rugged over last couple of years that we have started using them. In many sites, we use UNO SRPs that are bundled with limited tag web access SCADA to provide localized reporting and dashboards, as well as, if necessary, these SRPs synchronize the data with backend systems. On top of all this, we as Mirai offer complementary VPN services to our customers with all Advantech products that we sell to them. The advantage of VPN, we will get into that later, but it has brought in a big advantage. This VPN is also supplied by Advantech, which is Web Access VPN. We have over the last few years in partnership with Advantech been able to deploy and service almost like 150 sites using various Advantech products: UNO 2484, UNO 1372, ECU 1051, ECU 1251, plus a lot of other products which go into the system there. The ones that I mentioned are the main products that we use in very large volumes. The key issue for us has always been the reliability of the product, even for the customer, of course. Over the years, we have experienced almost zero failures so far once we have deployed our products in the field. Therefore, in our experience, we have a proven product or a very reliable product from Advantech that we are continuing with and hopefully would continue with these products in future as well. Our on-premise and plant located software systems like Web Access SCADA or even UNO SRPs have also proven to be very reliable. So far, we do not have any adverse or any negative feedback from customers on Web Access SCADA, though of course initially there is always hiccups, but once those hiccups are overcome, thereafter we have not had any major complaints so far. Apart from all this, Advantech has, based on our feedback, added multiple features to their products. I would not go into the details of those products, but these have helped us improve our functionality of our monitoring systems, as well as have given a very advantageous position for Advantech in the market. In the following slides, we will show briefly some of the screenshots of some of the sites that we monitor almost like 24/7. We monitor, by we monitoring means our customers monitor, but we have supplied and implemented these sites for them. This is one of the sites, which is basically a floating PV in Singapore. You can see the description briefly on the right hand side, the capacity, the type, and on the left hand side you can see the menu and the dashboards that we have implemented for them, and we'll show you some screenshots from this site. This is the site that they generally look at. Their operations guy look at this almost every day. This gives a very high level or a macro level picture of whether the generation is ongoing correctly, whether the performance ratio is correctly. If in general this plant PR is above a certain value, they don't need to worry about the system operations. The system operations can be assumed to be working smoothly. At the same site, we have almost like 16 different kind of environmental sensors, temperatures, back of module temperatures, ambient temperatures, wind speed, direction, rainfall, as well as irradiance sensors. We read and historize all these data and then use them in the calculations for the performance ratio. In larger PV systems, especially the one that I was talking about, a large number of PV panels are combined together, and they use an equipment called DC combiner, so which combines output of multiple solar panels into one bus, and that is eventually then fed to the inverters. So each of these junction boxes or combiner boxes are also monitored. So this is a very typical combiner monitoring screen, whereby you have the status of the monitor at the bottom. You can see the red and the green dots, the breaker status, which is a major issue happening, which is the major alarm for the customers. So it is shown in a much larger view, the DC voltage and individual string currents. Customer monitors these string currents and to see if the strings are working properly or not. Some of the historized 15-minute interval data that we calculate for customer, not only calculate but also compute and historize, plus based on this we do other calculations for customers. Some of the tags that the customers can view. Lastly, I would like to thank Advantech for partnering with Mirai, and we have had a very positive experience with Advantech and Advantech products. The support is excellent. By offering joint services and products with between Mirai and Advantech, the main feedback that I would like to provide today to the audience is our customers have brought down site visits considerably. Not firstly by having a remote access, so anytime they can interrogate the system, they can interrogate the devices, they can interrogate their sensors to see the health of the sensors. They can have this access 24/7. That's one part of it. The second part is the products are very reliable. We do not have to go to the site that often that they used to with the older kind of systems that was like PLC based with no GUIs and all those things. So I can say with a very high level of confidence that the site visits to attend faults has come down considerably. I would safely assume that the site visits have come down to by almost 50%. Customers get a real-time abnormality reports. For example, with one of our customers, for some reason there have been an abnormally high number of fan faults. So they once they came to know that there has been a high number of fan faults, they have kept the fans in stock as spares. Once they get informed that the fan has failed or any of the other components has failed, they immediately go and replace it. Thereby they keep their generation at a very high level, offsetting any revenue loss they might otherwise have incurred had they not been informed of the fault or had they not kept the identified component in stock. Apart from that, customers do get a daily report on their performance of the system, and if they see and analyze any kind of abnormalities in the performance or generation, they would attend to it on a regular basis if necessary. With this, I close my presentation, and I hope and thank everyone. I hope this has been a useful introduction as far as the solar PV monitoring systems are concerned, and I thank everybody for being present today. Thank you.
Okay, this is Sharon. I will share more on the simple demo using the EdgeLink the EdgeLink Studio software using the ECU 1051. Right. So before we start our project demo, actually you will need to understand two things, right? So we call the two component. One component, if you want to do actual project, definitely you must have actual hardware, right? So we did mention to you in the previous slide, our EdgeLink the software is not traditional software alone, right? So they will bundle with our hardware together, right? So one of the component you will need the hardware, real hardware, right? So second component is our EdgeLink Studio. You also can call the tools. You also can call the IDE, right? So you will use the EdgeLink Studio, this software tools to configure all the project configuration, right? So this one you will need to use another system, or like the any PC, the one is running on the Windows. You can install EdgeLink Studio software in your PC and do the configuration. So these two things you will need to do for your real project. Okay, so for this demo section, definitely you will need to install some software and also share some of the test tool for today's demo. Right. So I did mention to you is you will need to install EdgeLink Studio software, right? So EdgeLink software, this is the download link I will share in this slide. So another these two things is why I did share to you is one is a software configuration tools. So another one is the EdgeLink, the image, right? So if you buy any Advantech hardware itself, because our software is keep on updating, right? So keep on updating. Maybe every quarter, every half a year, they will be keep on updating. So you will need to be checked what is your actual hardware, actual EdgeLink runtime hardware you are receiving, right? So hardware you are receiving, they will have an EdgeLink runtime, they will build in together, right? So this is a very important thing. That's the reason I put in the EdgeLink, the image download link also will be here. The third one is FAQ, right? So FAQ is mostly we are sharing is some of the use case real cases, some of the protocol configuration. We just make it to be FAQ and share into this link, right? So this three is the very important, right? If you use our SRP hardware, right? So SRP hardware, right? So this area is I will use the three software for my test tool, right? So my demo section will be cover data acquisition, right? So I will cover data protocol conversion, right? So maybe Modbus RT convert to Modbus TCP, right? Data protocol conversion. The third one we are saying that is our hardware itself will be provide the web service, the web server running in the built-in web server. So you can use the RESTful API to query your data, right? The one is the MQTT. Please take note is our hardware itself only will be supported MQTT client, right? So if you look at our FAQ, definitely they will share. If you want to be run MQTT broker in our Linux platform, they will have some link will be there. But original image will not come with the MQTT broker will be there, right? So our hardware is client, MQTT client. They are doing for the publishing and subscribing. This is the MQTT part, right? So for the Modbus, I will use the mod scan. For protocol conversion, I will use the mod scan to prove that is the data is can able to read there, right? So second one is the RESTful, right? RESTful itself, one of the software is we call the RC, the RESTful Client Tester software is provided by the H2 side. So they will put in our FAQ link also, right? So another one is I will use one of the FAQ they will share to you because this one is the web server, right? We are designing for the HTML5, all these things, right? You can as long as you are using web browser and you just run extension to be the REST client software, you can be able to test whether the RESTful function is workable or not, right? So you can use these two methods. RC, definitely you will need to be installed in your system. The browser is you just install the extension any browser, you can use the web browser to do a REST client also, right? So the one I use in my system is the Talent API tester, right? So that one is the MQTT box to test for the MQTT client. But this is my simple architecture. So I'm using is our Advantech hardware is using serial device, serial communication, right? The one is running Modbus RTU, right? So this is the one is Modbus RTU. ECU will be query the data. So we will be use the ECU Modbus server. I did reconfigure in here, right? So we also will use the web RESTful API to do a test, and then I will use the public MQTT cloud services. I'm using this one. I publish to this server. I will use the MQTT box to query all this data. Right. So this is the simple step when you create the project in our EdgeLink, the studio, the software. One is the because this slide is that we just consolidated it in one page. Maybe I will share with you is what is the actual really the project, the outlook is look like. Right. This image is very small. You may not be clear, but I explained to you is you only need to do a few steps. You can be configured for your project file. Right. So first step is definitely you need to be select what is the hardware you are using. Right. When you create the project file, first step you need to be select and create which hardware you will be using for this project. Second one is for the communication. Right. So if you want to be querying the data, what kind of the communication you will be using, serial or TCP. Right. So this is for the communication part. So this one is slave device. Based on this architecture, this one will be our slave device. This one is we call the master or client, right? It's the TCP client. This is just for the naming. RTU serial, they will use the master and slave. TCP, they will use the client and server, right? So this is just the term definition only, right? So this is your device information, right? Add-in information you need to be created, or what is the communication setting they're using there, right? So based on your device, yeah, I'm not extracting, I'm not acquiring all the data, right? So you can be add in because this add-in is a 8 input channel, 8 input output, right? So you can be select which channel, which data you want to be query. So we call the which data, which channel you want to be query the data, receive the data. This one is mainly is we are seeing for the protocol conversion, right? So all this data, right? I want to use the MQTT to publish the data, right? So this one is for the step 5, mainly is for the protocol conversion, right? Protocol gateway, protocol conversion purpose. After you have done, the last step is you just need to be saved and download the project file to actual device, right? So I did mention to you in here, right? So you will need your actual hardware. You will need your configuration tools in your PC, right? So this tool is the two hardware, two platform, right? So you have done your project in your PC. After that, you will download all the project configuration file to your actual hardware, right? So they will receive all this configuration. They will start to do their own tasks, right? So this is the 6th step. Okay, I will share to you is first step, you will need to be install our software IDE, right? Software tools. This we call EdgeLink Studio, right? After you did install that, you will be, this is the icon, right? So this is the icon will be look like, right? So because of the time frame, right? So I did predefine that the project file is running here, right? This is the outlook for the EdgeLink Studio software. What's the outlook? I did mention to you is 6 steps, right? This is the project. After you create the project, this is your actual device, right? This is the model, which hardware you are using, right? Second step is for the communication. Communication is data acquisition, right? So where you can do for the data acquisition under data center, right? So this is the data center. You just, okay, so before I move on this thing, I will show something to you, right? So you will be see from the camera, right? This is the actual hardware, right? This is the Adam, the one I'm using for the data acquisition, right? So if you look at from here is actually our hardware is they were mainly they're doing their tasks. They are not coming with the visualization, right? So they only do for the application for data processing, right? So that's the thing. Most of the hardware they only come with the communication part. You will see from here, right? So this two is the two lamp port, right? This two is for serial COM, right? Please take note is our serial COM port. We only support two types. One is RS-232 and 45. Default is the IS-485. Okay, so LAMP1 and LAMP2, right? COM1 and COM2 mainly is for the communication. So this is for the power inlet, right? So this one is additional information, not related to my demo, right? So I did mention to you is some of the hardware is not coming with the USB port. If you look at from my hardware itself, there is no USB port, it's here, right? So if you want to do for the data logging, you will be see from that, this one is the micro SD slot will be here, right? This is the one slot. Okay, so now hardware is connecting to the COM1. So right, so COM1 is the communication port. You will need to be okay. This is the COM setting we did is configured. Definitely, your COM setting have to be matched with your actual hardware, like our Adam, right? So these two hardware is all the COM setting have to be matched, unless they cannot be able to receive all the data, right? So this is the COM setting. Second step, right? Choose your device. Second, communication part. This is your hardware, right? So what's the hardware? Our hardware, I just give the name is the Adam 4055, right? Our protocol is for the Modbus RTU, right? You will be see from here, Modbus RTU, right? This is for the slave device information, right? So the fourth one is which information you want to reading, right? So I created two channel of the input, two channel of the input, two channel of the output. I want to do simulation, right? So I will be using this one, 4 channel. If you look at my video, right? So actually this is the one switch, just a normal switch. I just do, right? So I can do is a simple test. Normally is the whatever we make the wiring, right? So we just do the simple test. If you press, you have to see the LED will be on, right? That's the meaning that signal, the wire connection is working, right? So this one is physical signal come to the Adam module is working, right? So the only thing is we will see that this is for the 45 communication, right? I just use the separate wire. This one is for communication. This one is for the power line. This one is just for the simulation purpose, right? Okay, so we have done for the step 4, right? So step 5 is we are saying is protocol conversion, right? Based on my slide, I did mention to you we will test 3 things. One is the Modbus server, okay? Second thing, RESTful. That one is the MQTT, right? So if you look at second step, we call the service. What kind of the service? What kind of the protocol service we will be supporting? One is the Modbus OPC, right? So I did mention to you, this two is the example. Today we did sharing, right? So if you look at from the Modbus server, this is the server, right? Server, I'm still using this port address, right? This is the 4 data, right? This is the port address. This is I have done the created for the Modbus server. The RESTful is the big in web server is running. We don't need to do anything, right? So actually we don't need to do anything, okay? For second demo, right? So the top one is the MQTT, right? So I'm using is the open source, the HypeMV, the public MQTT program, right? So I'm using is the simple MQTT. In our slide itself, we did mention to you is we are supporting different kind of the cloud platform. You have seen that Azure, AWS, all these things, right? So to make it to be simple, I'm using is the simple MQTT, right? This is their connection, right? This is the port, okay? So I'm publishing all these 4 data to here, right? So for MQTT, the setup, I just set up for two things. One is the periodically update. Every 30 seconds, oh, sorry, this is for the timeout. Every 10 seconds, they will be update one data, right? Second thing is when the value is changed, okay? This is the one. When the value is changed, we also will be update the data. These two things, right? So I did configure that. For MQTT, the topic is set. I did change a little bit because when I set up for my demo, I saw that maybe some of my colleagues or other customers, they also using this freeware HypeMB, the public cloud broker, right? So they are still using. So the topic is the conflicting. I did try that. So I did change that my topic to be Advantech, data, issue, blah, blah, all these things, right? I just put it to be the my naming, right? My customize the topic will be here, right? You also can make it your own customize, okay? So this one also the comment, another comment. This one is for the subscribing, right? The topic we are publish and subscribe. We are using is the different two topic, right? So after that we have done, right? So we just select now. We just select your actual hardware and save and download, right? All this step is the same. You just click download, right? So this one will be down. So the next step is because this project is I did pre-configuration, right? So actually we don't need to do anything. We just need to test whether the Modbus server is working, whether the RESTful is working, whether the MQTT is working, right? So we can test it one by one, right? So for Modbus server itself, we are using is mob scan. Am I right? We just run the mob scan. Right? So the thing is, if you want to get the data for Modbus TCP, you will need to be know two things. One is the IP, one is their port, or the device information, right? So our one Modbus server we have created is the quiet value. Our data is port address, right? So we are trying to connect to our ECU. This ECU is a LAN 1. I am connecting to my PC. LAN 2, actually I am connecting to our internet line because this internet line I want to publish to HypeMB broker. Right? This one is the public cloud. So public services now. I will say the public one. So I need to use the internet. So LAN 1 is for the local network, connect to my PC. LAN 2, I configure. I didn't configure because the one is the DCP. Default is the DCP. LAN 1 I connect to our internet line, right? So after you have download, I forget to talk to you one thing. Is that before we test the protocol conversion, right? We need to make sure whether the data is correct, whether the communication workable, right? So I will share something to you, right? So because the one is the Modbus RT we are using is RS-485. If you look at from this label itself, they will have the transmit and receive LED, right? As long as you see that transmit is data is going out from the ECU, right, our hardware, and then the receiving bit is coming from our ADEM, right? As long as you are seeing is transmit and receive LED is blinking, that's meaning that communication part for the 485 is working. Okay, so we just want to make sure physical wiring is workable, communication is workable, right? But this one, the next step is we just use the LAN cable, right? We just step for Modbus Modbus TCP, right? Protocol gateway. We are saying is first step. We are testing for the protocol gateway. We just here, right? So let's say if I press this one, all right? So if you look at my camera, right? If I press this button, LED will be on. You will be see that my address 1 is 1. All right. So this one, we just make sure that our Modbus server is working. Protocol conversion is working. Right. This is one of the methods. You can test for the Modbus server. Right. Okay. The second one is RESTful API, right? I did mention to you is we have two methods, right? RC, right? RC REST client test 2. This is the one you will need to be installed because the one is normally is used in our HQ. You will need to be installed this thing because all this information you can get it from our FAQ, right? Let's say if you need it, you can drop the email to us. Maybe I will share all this information to you for this training after this webinar, right? So this is the one you will need to be installed, and then you just run it, right? You just run it. They also will come with the one of the FAQ for how to test our REST API, right? So first step before you get or query any data is that you need to get one of the section ID, right? So you need to log into the web server and then you will get the data, right? So all this thing is that you just need to follow about this FAQ. I also just try to use this FAQ to test it how the way REST API is working, right? So to be faster, I just copy all these things, right? So you have to be logged in there, right? You just, this is the URL for the REST API, right? Second thing is you want to use the put method to get the section ID, right? So second one is the you have to be key in all the header, right? So these two. One is the content we are using is the application JSON, right? Our data format is the JSON format, similar to that one. Referrer, definitely you will need to be put in the referrer. So for this section ID, maybe I will remove it first, okay? These two, you have to use the push method. You want to do that. You have to be key in the header, right? So body is the, whatever you want to look it, our username is the group. Password is the 8-digit 0. This is the default one, right? So I just put in the password is 000 8-digit 0 right here, right? Please take note a few things is SSL certificate one because last time is when we use the third party we encounter a lot of issue. That is the reason HQ they find out one of the test to test for our REST API, they recommend to use this test too, right? So this is the one, we just follow this one, and then you just press this arrow button. So you will be see from here, right? You will get all this section ID, right? Maybe I want to test for another query. I just copy all this section ID will be here. Okay. So the next step is I want to get all the tag information, right? So what is their URL? This is the URL. The first portion is the same. Only the last part will be different, right? So you will need to change your URL, okay? So the method is the get. We want to get the data, right? We are not to write any comment, right? So we want to get the data. Header, you will need to be in section ID. We call this one will be under cookie, right? So the key, you have to be key in the cookie, right? Section ID, okay. So I did, because when I do the testing, I faced a lot of one issue in here, right? So I did share all of you over here, right? So if you look at our FAQ, you know, so you will be see from here, right? After you get the section ID, you obtain the section ID, right? So after you get this section ID, you will get you try to query your data, right? So you use the get method. You will need to clean. If you look at carefully from here, right? Last time the name they're giving is the Adam section ID, right? So this document all the way is working in EdgeLink image version 2.8.0, right? So because the next quarter, next few months, we will be releasing the version 2.8.1, right? So because of our Mirai, we did share a lot of the success story will be there, right? So we will use this latest image for some of their WIP project. So I use this image in my testing, right? I encountered that this section ID for version 2.8.1 is no Adam section ID. Okay, so if I add in the section ID, or the capital letter, you should not be put the Adam, right? So we just copy all this section ID, come to here, right? Add, and then you just query all this data. You will be see that all of your data will be here, right? You have to get all the REST using the REST API to get all the data. You just need to take note one thing, even though you follow our FAQ, just take note. Header for cookie section ID change to SID, right? Not Adam section ID. Okay, please take note one thing, right? Second method I'm using is the web browser. This is the you just put in the extension. This is the look like. All the testing exactly the same. I can able to get all the data. Okay, so the third one is the MQTT client, right? So this is the topic, customized topic I created in our ECU. If you subscribe, every 10 seconds you will be see that Adam 0, channel 0, 1, 1, 2. Total is 4 value, right? So if you look at from here, right? If I trigger all this thing, maybe this one is covered a little bit. Okay, because the one is the a little bit long, so you will be see that some value is coming here, right? This one is subscribe is successful, right? So I will share how to use the publish and subscribe is how the way publish and subscribe is workable, right? So this is the topic for the publish from the client side, right? This is the format. This is the payload used for our ECU. They will you just go to our head file. They will guide you how to use the payload, right? So let's say if I want to trigger channel 0 and channel 1 at the same time, right? So I will show this camera to you. If you publish this one, 2 channel, right? You will be see from here, right? 0, 0, and 1 is triggering on, right? This is the payload, right? They will need to get the tag information. You have to put in the timestamp. You just publish your payload too, so you can able to trigger this one, DO status. Okay, so this is my simple demo for three method. One is the creating for the mobile server, and then how to test the RESTful, how to use the MQTT box to test for the MQTT the client in our hardware, right? So this is my end of slide. If you have any question, you just let us know. Thank you, everyone.